Namaste and welcome back to JEE Chemistry with Typical Monk. This is class 21, the P block, groups 17 and 18, two neighboring groups, two opposite temperaments. Group 17, the halogens, sit one electron short of a full shell and are the hungriest oxidizers in all of chemistry, with fluorine the fiercest of them. Group 18, the noble gases, already hold a full octet and famously refuse to react. And yet fluorine is so fierce that it forces even xenon to bond. Xenon difluoride, xenon tetrafluoride, xenon hexafluoride. Today, both groups and their beautiful shapes, one idea at a time. Here is what you will master today. First, the group 17 trends and the anomaly of fluorine. Second, the acidity of the H-acids and the oxoacids of chlorine. Third, the interhalogen compounds, chlorine trifluoride and its T-shape. Fourth, group 18, the noble gases and the xenon fluorides like xenon tetrafluoride. And fifth, their uses plus the full drill suite, one idea at a time. Let us set the two groups side by side. The halogens, group 17, fluorine, chlorine, bromine, iodine, astatine, each one electron short of the octet, and the best oxidizers in chemistry. The noble gases, group 18, helium, neon, argon, krypton, xenon, radon, each with a full octet and famously inert. The bridge, fluorine's fury forces even xenon to react. Xenon difluoride, tetrafluoride, and hexafluoride are all real compounds. Master line, group 17 grabs an electron. Group 18 already has its full shell and mostly refuses to share. Now, the periodic trends of the halogens. Electronegativity, highest for fluorine, the most electronegative element of all, and it falls down the group. Electron affinity, chlorine is the exception. It actually exceeds fluorine, because fluorine's tiny size crowds the incoming electron. Oxidizing power, fluorine is the strongest oxidizing agent in chemistry, and the power falls down the group. Bond enthalpy, the fluorine to fluorine bond is anomalously weak from the small size and lone pair repulsion. The chlorine to chlorine bond is stronger. Now, a beautiful family, the interhalogens. Look at the picture. Interhalogens, formed between two different halogens, in four types, AX, OX5, and X5, and X7, like chlorine monofluoride, chlorine trifluoride, bromine pentafluoride, and iodine heptafluoride. Chlorine trifluoride is T-shaped, sp3 dehybridization, with 3 bond pairs and 2 lone pairs. More reactive, interhalogens are more reactive than the parent halogens, except fluorine, because the A to X bond is weaker. The rule, the larger halogen sits at the center, and more small atoms fit around it as the size gap grows. Now, the odd one out, the anomaly of fluorine. Tiny and greedy, fluorine is the most electronegative element with the smallest size in its group. No d orbitals, so fluorine shows only the -1 oxidation state. It never takes a positive one. A weak fluorine-fluorine bond, its small size crowds the lone pairs, so the bond is weak and fluorine gas is intensely reactive. Hydrogen fluoride is special, a weak acid and yet a liquid, both owing to strong hydrogen bonding. Hydration. The small fluoride ion has a very high hydration energy, which drives many of its unique reactions. Now, a shape no chemist once thought possible. Xenon tetrafluoride. Look at the picture. Xenon tetrafluoride is square planar, with 2 lone pairs, one above and one below the plane. Hybridization, sp3-2, 6 electron domains, 4 bond pairs and 2 lone pairs. The lone pairs, they sit opposite each other, perpendicular to the square, to minimize repulsion. The family, xenon difluoride, is linear, xenon tetrafluoride is square planar, and xenon hexafluoride is distorted octahedral. Now the acids. First the hydrogen halides, then the oxoacids of chlorine. The He-X order, acid strength rises down the group, hydrogen fluoride, then hydrogen chloride, then hydrogen bromide, then hydrogen iodide, the strongest. Why? the hydrogen to halogen bond enthalpy falls down the group, so the proton leaves more easily. Hydrogen fluoride is weakest. Strong hydrogen bonding and a strong hydrogen fluorine bond keep it the least acidic. The oxoacids of chlorine, hypochlorous, chlorous, chloric, and perchloric acid strength rises with each added oxygen. The twist, perchloric acid is the strongest acid, but the oxidizing power runs the other way, with hypochlorous acid the strongest oxidizer, and chlorine bleaches through it. Now, group 18, the aloof gases. Inert, a complete octet, and for helium, a duplet, makes them the least reactive elements of all. Xenon reacts, only xenon and a little krypton form compounds with fluorine and oxygen, xenon difluoride, tetrafluoride, hexafluoride, xenon trioxide, and xenon oxytetrafluoride. Uses helium in balloons and in diving mixtures, neon in glowing signs, and argon as an inert atmosphere for welding. Now match each molecule to its shape. Xenon difluoride goes to linear with sp3 and 3 lone pairs. Xenon tetrafluoride goes to square planar with sp3 and 2 lone pairs. Chlorine trifluoride goes to T-shaped with sp3d and 2 lone pairs. And xenon hexafluoride goes to distorted octahedral with 1 lone pair. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. Fluorine is the strongest oxidizing agent among the halogens. Correct. Statement 2. Hydrogen fluoride is the strongest hydrohalic acid. Wrong. It is the weakest. Hydrogen iodide is the strongest. Statement 3. Xenon tetrafluoride is square planar. Correct. 2 lone pairs, sp3 So, the answer 2 are correct. Statements 1 and 3. The trap is the acidity of hydrogen fluoride in statement 2. Now the 2 mistakes that quietly cost marks. The truth, halogen acid strength rises down the group. Hydrogen iodide is the strongest, hydrogen fluoride the weakest. The trap, assuming fluorine has the highest electron affinity, chlorine actually exceeds it. The second truth, the noble gases react only for xenon and a little krypton, driven by fluorine and oxygen. The second trap, calling xenon tetrafluoride tetrahedral, it is square planar with 2 lone pairs. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. The most electronegative element? Fluorine. Question 2. The strongest hydrohalic acid? Hydrogen iodide. Question 3. The shape of xenon tetrafluoride? Square planar. Question 4. The shape of chlorine trifluoride? T-shaped. And question 5. The strongest oxoacid of chlorine? Perchloric acid. Let us gather it all in one breath. Group 17. The halogens, the best oxidizers, electronegativity, and oxidizing power both fall down the group. The anomaly of fluorine, only the -1 state, a weak fluorine-fluorine bond, and hydrogen-fluorine, a weak acid with hydrogen bonding. The acids, H acidity, rises down the group, and the oxoacids of chlorine rise in strength with more oxygens, with perchloric the strongest. Interhalogens, chlorine trifluoride is T-shaped and more reactive than the parent halogens. Group 18. The noble gases are inert. Xenon difluoride linear, tetrafluoride square planar, hexafluoride distorted octahedral. Next class, the D block, the transition elements, their variable oxidation states, and their color. The halogens hunt for 1 electron and take it from almost anything, fluorine most fiercely of all, showing only its -1 face. The noble gases sit content with a full shell until fluorine drags xenon into square planar and linear geometries no textbook once thought possible. Hold the trends, the anomaly of fluorine, the acid orders, and those xenon shapes, and both groups are yours. Next class, the transition metals and their colors. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack G. I will see you in the next class.